Welcome to the training module on Lumex's QuasarBrite UV LEDs. In this training, we will go over the overview of UV wavelengths and applications, review of UV LED challenges, and introduce 3 new UV products from Lumex. Ultraviolet light or UV light is invisible to the human eye. This is because UV wavelengths are too short for human eyes to perceive. UV LEDs span the wavelength spectrum from 100 nanometers to 420 nanometers. Despite the potential hazards of ultraviolet light, which are evident in everyday life, such as sunburn, the UV spectrum is proven to have many beneficial effects in a multitude of areas. Not unlike how standard visible LEDs have impacted today's marketplace, the advancement of UV LEDs is offering a wide range of advantages to a diverse number of applications. This promising technology is moving the UV market segment into a whole new level of product innovation and performance. Within the wavelength spectrum, the range of UV light can be broken into 3 primary areas. The ultraviolet A or UVA long wave falls within the range of 315 nanometers to 420 nanometers. Ultraviolet B or UVB medium wave is within the 280 nanometers to 315 nanometer range. And finally, ultraviolet C or UVC shortwave is within the 100 nanometers to 280 nanometer range. Each area within the UV spectrum offers distinct benefits in industries ranging from medical to forensic science and to test and measurement. Many applications in today's marketplace are ideally suited for and already utilizing UV LED technology. Within the UV spectrum, examples of such applications include counterfeit detection, bodily fluid detection and analysis, polymer and ink printing, and medical light therapy and sterilization. There has been a marked increase in the adoption of UV LEDs for applications that until recently relied upon fluorescent UV lights. UV LEDs offer many benefits over traditional CFL UV lamps. For example, UV LEDs utilize much less energy than their CFL counterparts. UV LEDs are RoHS compliant and they are not toxic if broken. In addition, UV LEDs offer much smaller, more compact sizes than CFL lamps, and UV LEDs are much more resistant to vibration and impact. Until recently, the challenge of using UV LEDs had been stabilizing the dye at the wavelength needed. Recent advancements have overcome the stabilization of the dye, but challenges still remain in the packaging of the dye in an effort to yield the same life hours as existing standard LED technology. Standard epoxy packages usually provide less than 5,000 life hours because the UV rays break the epoxy down rapidly. Hardened or UV-resistant epoxy packages usually have less than 10,000 hours life, which is still not nearly enough for most applications, and the epoxy breakdown is erratic, not graceful or linear. One of the other major challenges of utilizing UV LEDs for any application is the efficiency rate. For many applications such as medical light therapy, water sterilization, and polymer curing at less than 365 nanometers, the output power is only 5 to 8% of the input power. At 395 nanometers and above, the efficiency improves, but only to 15%. The Lumex QuasarBrite UV LED family comes in 3 different wavelengths, namely 385 nanometers, 405 nanometers, and 415 nanometers. The applications at 385 nanometers include counterfeit detection, bacteria sterilization, and ink fluorescence. At 405 nanometers, one of the key applications is forensic analysis of bodily fluids. Finally, the 415 nanometer UV LED can be used in superficial sterilization, including skin treatment. All 3 LEDs come in a robust TO42 package with glass lenses, which increases life hours from 5,000 compared to an epoxy package to a minimum of 50,000 hours. UV LEDs have impacted today's marketplace, offering a wide range of advantages to a diverse number of applications. UV LEDs offer many benefits over traditional UV lamps, such as energy consumption, environmentally friendly, are more compact, and offer more resistance to vibration and impact. However, challenges still remain, such as extended life hours and power output efficiency. Lumex's new QuasarBrite UV LEDs overcome these challenges and extended the use of UV LEDs in ways that might not have been considered for applications in the past, such as counterfeit detection, forensic science, and medical devices.